guys all got your coffee? Well, you're not going to need it because this is going to be an exciting panel. My name is Jason Jerald, and I'm founder and principal consultant at NextGen Interactions, and I'm especially excited. The last couple years have been just the time of my life. I've been developing virtual reality systems and applications since 1996, and things have really been taken off and are continuing to take off. Now, 1996 may have been a while ago, but not as long ago as this head-mounted display here from about 1989. The Cyberface. This was used by Jaron Lanier in one of the original virtual reality companies, VPL. We believe this was built around 1989. This is from Paul Milenick of Sixense Entertainment, and make VR fame and digital art forms as well. And he wanted me to show this because it's a pretty cool introduction of how far things have come. I don't know what the resolution was on this, but it's certainly not what we have today. Okay, so what we're going to do is we're going to have each panelist speak a few minutes about kind of their experience, how they see virtual reality continuing to evolve over the coming years, and then I'll ask a few questions, and then let you guys come up and ask questions. So go ahead and write down your questions as you hear these guys speak. Up first, we have someone who's sort of resurrected the entire virtual reality industry in just a couple years' time, from prototype to, I'm sure you guys have all heard of Oculus VR. By the way, how many people here have actually tried some form of a head-mounted display, like the Oculus Rift or Sony Morpheus? Oh my God, that's like, what, 90% of you guys? That's great, because we can talk about VR, but it's something you really have to experience. Okay, back to Palmer Luckey, the co-founder of Oculus VR. As I mentioned, he's really, helped the industry take off. And I think we first met almost 2 years ago now. And since then, I've been very impressed because it's very easy to do virtual reality badly, but very difficult to do it right. And his team has certainly been doing it right. With that, Palmer, go ahead and take over.
It's always unfair having to go first on these things because you set the tone and then everyone gets to, learn from your mistakes. So you guys are going to sound so much better. Where do I see VR going? Right now, virtual reality has been primarily a visual thing, but I think that it's going to need to expand all of other senses, including touch and sound and balance, all of these things that right now we don't have perfect solutions for in VR. I think in the near term, that's going to involve creating peripherals that strap onto the end of all of our sensory systems, our hands, our heads, and our noses, and our ears. And I hope that at some point we are able to advance past that and connect on a more direct level. I'll get it out of the way. People ask all the time, when is this going to happen? I don't know. I don't even know if it'll happen in my lifetime, because this isn't something that you can have a roadmap for. It's about almost more medical advancements than technological advancements. And it'll be interesting to see how VR advances, but I think that if we can get perfect VR, we're not going to need to perfect much else.
Up next, we have Amir Rubin from Sixense Entertainment, and he's actually founded multiple companies that have dealt with motion sensing and motion control of virtual environments, or VR-like applications. And I've known Amir since the early days of Sixense Entertainment, so it's been definitely a journey knowing Amir. And I I never had the chance to meet Steve Jobs, but if I ever did, I think, Amir kind of reminds me of how I would think Steve Jobs would be. I didn't say if that is a good thing or a bad thing, but the reason why I say that is because Amir doesn't accept the status quo, and he doesn't accept anything less than, the highest quality. And so that's something I've grown to really respect about Amir. Amir?
Thank you very much. It's going to be hard to follow that. First of all, I want to thank for, thanking Palmer Luckey and Oculus VR for making virtual reality a much more viable and a much more exciting space to be in. I would ask you all to just thank him, anybody that is interested, and I'm speaking for Sixense, I'm speaking to Sony, and I'm speaking to everybody else that I'm working with from the developer community and everybody else. So as a start, I want to personally take a moment and just tell you, you've done amazing.
Nobody clap, nobody clap, stop.
That's a beginning. Then I've been trying to live a dream as an Israeli soldier, and then continued. I've been training with virtual reality, and I've always felt that this is something that consumers should be able to experience. I've worked on it since the 90s. There was no market for it in the consumer market. I worked in the professional market, and the vision was enable presence in 3D worlds, enable you to feel in virtual reality the same way that you feel in the real world. Professional simulation is supposed to be doing that, you know, military simulation and sports simulation. But of course, it's overpriced, and over many years, it was not possible. We focused on the missing link that we identified, which was the input device, the human-machine interface. We figured that if we can make it intuitive, being in virtual reality, being intuitive, we will meet our mission. So we continued for the past 6 years in developing the technology to enable you to see your hands, your body, and the rest of your, all the way to all your senses, coming down to your intuition. Name the company Sixense for that purpose. Enable you to use your sixth sense in virtual reality. So for me, very much like Palmer just said, if we can live within virtual reality and benefit, and the benefit is way beyond gaming. The benefit, if it's going to be intuitive, you'll be able to be educated better, you'll be able to be rehabilitated better, you'll be able to almost do anything better because there's less risk, it's more accessible, and now, you know, with the last missing link being the HMD taken care by Oculus VR, and obviously by Rick here with his Magic Lab in Sony, and I expect every major consumer electronic company to follow. I expect the dream to be, you know, to be here, and I would like to say to be here, you know, within the next 5 years.
Thank you, Amir. Up next, we have Richard Marx from Sony, and I remember Richard Marx seeing one of his demos we were discussing earlier. I saw a demonstration at SIGGRAPH 14 years ago that was a precursor to the Sony iToy, which was a precursor to the Sony PlayStation Move. So what he's created is actually shipped millions, if not tens of millions by now, I'm not sure, lots of units. And his background is he has a PhD in aerospace robotics, focusing on computer vision, so it makes sense that he developed the iToy. And he is the director, get this, the PlayStation Magic Lab. How cool of a name is that? So one of my first questions before you talk maybe is, did you make up that name, or who got to make that name up, of the name of the lab?
Yeah, that's definitely my influence on the name. And had to fight some people for that name, but a lot of people like it, so I'm happy with it. So back to VR. As you mentioned, I've been working in this industry actually for PlayStation for 15 years now, and when I started, graphics was the big thing, and I really felt that input technologies were lagging behind graphics at the time. So we focused on input with cameras and other sensors. And that kind of turned into the golden age of input and sensing right then. So it was a good time to do it, actually. But then it almost is like we kind of ignored the display and output technologies a little bit. And now I think with virtual reality, you're seeing all this kind of combined together, the input and the output, both pushing the envelope together. I mean, you couldn't really do anything in VR without having all these things working together. The sensing is really important for the tracking, the display technology, the graphics technology, audio. All this is really important to make a good experience, and that's where we are right now, and it's a really exciting time for it. I really feel like it's just at the takeoff of the ramp is right what's happening right now, and that's a great time for it.
Thank you, Richard. Okay, up next, we have Anna Maiques, who is really an expert on the neuroscience side, but also integrating neuroscience, sensors and such with virtual reality head-mounted displays. And Anna is the founder of Star Lab, which is one of the leading research companies in Spain. And she's been named one of the most influential entrepreneurs under 40, and also listed as one of the most innovative women in Europe by the European Commission, among other awards as well. And more recently, she's the co-founder and CEO of Neuroelectrics. Anna?
Well, thanks for the invitation. Thanks to Zach Lynch and Casey for organizing this great event, and to Jason for coordinating all of us. So it's a pleasure to be here. Now you have a neuro excuse to come to Barcelona. So next time you can come to see us as well. In terms of the question on where is virtual reality going, our expertise at Neuroelectrics is on the medical side, and now I'm going to make my show. So Rick, can you hold this for me? So now I'm going to put this on. Thank you. So nice of you. Your magic, eh? So this that I'm wearing is not only a brain. Thank you. No, it feels good. This is not only a brain monitoring technology, so a wireless EEG with up to 32 channels, so I have positions all over my head, but it is also a brain stimulation device. And I know this question was raised on the last panel about writing into the brain. So we are applying electrical currents into our brain. This is called transcranial direct current stimulation, and what it does is either excites or inhibits the activity of your neurons. So, for example, in a post-stroke patient, maybe your motor area got damaged because of your stroke. So if you're doing physical therapy with your arm, and I'm stimulating your motor area at the same time, I get an enhancement of your therapy. This experience in the medical community started to make us to think about virtual reality and the Oculus Rift. So we have integrated our brain monitoring and stimulation technology with virtual reality, and this is now being used in veterans hospitals for post-traumatic stress disorders because the dropout rate of exposure therapy is up to 50%. So the virtual reality is helping a lot. We are also working with patients with neuropathic pain because, for example, spinal cord injury patients, they are looking at a visualization of the legs in movement. This is activating also their motor cortex, and then we are zapping the brain with electrical currents, and we have very good results on neuropathic pain. So I'm so excited to see how virtual reality, stimulation, and brain monitoring, this kind of closed loop, is helping all these patients that I'm very confident about the future. For children, they were calling this the Mickey Mouse cap, so excuse me, Disney. So we made some ears cover to our device to make it friendly in the hospitals. And you have really great teams even here in California working on non-medical but very fascinating applications like cognitive enhancement. So this opened a new door. The work that, for example, Adam Gazzale is making in UCSF is very, very impressive. And I recommend you to follow that closely. We have groups also in Oxford, Roy Cohen-Kadosh, helping children with mathematical disabilities by stimulating their brains. So I think the future is very bright in the medical community, also in the consumer market. And to show that, we hope we can get into everybody's homes with this new design. So this is fully integrating the Oculus, some headphones, and the brain monitoring and stimulation technology. So I hope you all will wear this soon at your homes and be much happier, much healthier. And it's a pleasure to be with all of you. You have demos outside if you want to play with our technology. Thank you.
Thank you, Anna. All right, I'm going to actually start with a question from Zach Lynch, the chair of the conference here, about something that's maybe on everyone's minds. And this first question is actually specifically for Palmer. And I think maybe, Palmer, you've heard maybe something about this, but Facebook recently acquired your company for $2 billion. And we all know in the audience here that was just a play to get into NeuroGaming, but we thought you might be able to add some additional insight about how that might affect now that there's more involved, how that influences the future of virtual reality and NeuroGaming.
That is a huge topic. The core thing that they're going to be able to help us with is massive resources. Facebook is a huge company, and they have incredible resources on the server side, on the user side, on their technological know-how side, but very significantly on the monetary side. And virtual reality isn't something that you can do very cheaply. It's interesting because all of us are working with hardware, and I think we all know how difficult it is to launch a consumer hardware product, especially when you need to have some kind of critical mass in order to get to mass market. With a software product, you don't have any overhead. You don't have to make 1 million copies for a couple $100 each before you sell them. You can just scale organically as you go. And it's really tempting to think that a hardware company could do the same thing, that you can scale organically, that you can just slowly go over time and hope that eventually you grow up to the scale you need to be to get to the mass market. But unfortunately, as time went on, it became clear that the kind of resources it was going to take to really make virtual reality happen, for it to penetrate into the consumer market, it was going to take an ungodly amount of money. And Facebook is really going to be able to help us with that, not just what they've helped us with so far, but they're going to continue to invest in it in the next few years. And if you listen to Zuckerberg's shareholder call, he said that he saw Oculus as a 5 to 10 year play till it's making money. And it's nice to think, oh, no, we're going to make money earlier than that, but it's a lot nicer to know that you have a bit of a runway to keep investing into technology and not have to worry about making it profitable right now, but worry about making the best thing possible for consumers, and knowing that if it takes off, prices are going to continue to come down rapidly. And we're in the same building, and we're doing the same thing and operating independently, and Facebook's logo will not be on the headset.
Unlike the cyberface like we have here. It's interesting they acquired you instead of cyberface. Okay, with that, we'll move on to some questions. I'm specifically interested, because this is a NeuroGaming conference, of how these sensors, these neuroscience applies to virtual reality. And I don't know if that's further out, or maybe it's something, Anna, you said that today you're actually already starting to do those sorts of things. And so I think that's my next question specifically for Anna is, what are the most important things, and you kind of talked about this a little bit in your introduction, that neuroscience or sensing can contribute to virtual reality gaming?
Well, I think that games are a powerful source, of therapy, and if you have children, the way they interact with games is completely different to the way we interact. So I think that virtual reality has high potential. As you know, the cover of Nature was made a few months ago on a NeuroRacer, so a game. So for the first time, I think that this convergence of neuroscience and games is showing that if you design a game properly, you can really increase, or for example, decrease cognition decline. This study was made with patients 60 to 85 years old, and they really improved their multitasking and cognition thanks to playing this NeuroGame. So I think that the potential is there. I think it's really good that the two communities, the neuroscientists and the gaming, are coming together, because I really see every day in hospitals, we are selling our devices in more than 30 countries to the medical community. They are really eager to embrace these new kind of technologies, because the patients are asking for new ways to be treated. So I think that it has very high potential if we bring both communities together.
And that actually leads to a question of, I'm curious, this seems like, maybe because it's two complicated technologies coming together, but why there hasn't been more work of mixing neuroscience, at least that I'm aware of, maybe the audience is more aware of them coming together, but virtual reality technologies mixed with neuroscience concepts. And maybe all the panelists might have an answer to that.
So before, can you hear me? Yeah, good. Before I even go there, to immediately answer your question, I want to add a little bit to what Palmer said earlier. I believe that, you know, from Sixense perspective, it's a little bit easier to answer the question about the contribution of the Facebook Oculus partnership. I must say, it is the number one value add was moving it from our small, you know, and very, very, very excited early adopter technologist community of maybe, you know, a few tens of thousands around the United States, some in Europe, to a mass appeal to the billion plus of the Facebook, you know, members. And that by itself is the number one most critical piece that was achieved, and I feel that that will make all of us that are involved in the field benefit, not only the $2 billion. I believe the $2 billion is just a beginning. It's great for Palmer, obviously, and the rest of his team. But for all of us, you know, for me, it's been a long, long time dream. Now, going straight into how is it helping neuroscience, and how gaming is meeting neuroscience. I'll give you an example. Sixense being for the past 5 years involved in rehabilitation of, specifically for the past 4 years, rehabilitation of stroke victims and other type of head-brain injuries. And we've worked with companies around the world, but specifically one company is treating stroke victims in a way that they took a whole new approach, which was very unique. They created a circus-type game. And the circus-type game was a direct translation of a 10-year study that a very famous British neuroscientist created. And the moment they moved it, what they call in a gamified fashion, and the moment they moved it into the research stage and did clinical testing, the results were just straight out, in percentage-wise, was 2 to 3 times more effective. The speed of people regaining their motor skills on the hand, the ability for the people to actually gain all sorts of different capabilities from memory and others that were not possible. Now, with us putting a lot of pressure, again, the medical space is very complex and doesn't like to adapt things too soon. We push them into virtual reality now, and we provided them a couple of the dev kits, and they've done some testing. And again, they're saying that, you know, by immersing people more, you get better results. And straight out, you know, using between our technology, allowing the people to have their hands in the world and the rest of the body, and the HMD, the Oculus specifically that is being used, allowing them to basically have their presence in VR. The combination of the two is there to allow extreme results.
So I've just recently started working with Adam Ghazali from UCSF, actually, and it's really fascinating. We have a lot of interest in working with him in different areas. One is just the idea of using games as a tool to stimulate your brain in different ways and be able to improve your brain with the complex feedback loops is where it gets the most interesting, and that's what Anna works on, I think, is actually providing the input to close the loop directly from the brain. You can do some of it through the controller inputs that a gamer would use in traditional inputs, but it's even more interesting when you have some of the more exotic sensing, like the brain sensing or the maybe eye tracking or something like that, are you know, really interesting inputs. And then if you look even further down the road, it's really interesting to think about the work we were talking about, where you can change the plasticity of the brain, and you could learn quicker if you are able to stimulate the brain in a small amount of way. And so you could actually put on something in VR, experience something, and you would learn it in a quicker way than you could even learn in real time in the real world because of this plasticity change. That's just, you know, that's science fiction, but it's really not that far.
No, it's not. It's in the back. No.
That's really cool stuff.
Well, even so, we have seen some studies show that if you monitor your brain in a certain frequency, so your alpha frequency may be at 8 hertz and mine may be at 10 hertz. So if I record your alpha frequency and then I stimulate at that correct frequency, I mean, you can personalize that potential. So I think that there is a lot that we will be seeing in the future about how to personalize, your brain, cognition according to the reaction to certain stimulus. So I think it's just the beginning, but I hope that we'll see, not in less than 5 years, a total revolution on the way we interact with the brain. And I think we want to be game changers on that and really change completely how we are going to interact with our own brain in the future.
And I think we haven't seen it so much because they are fairly exotic. I mean, VR is fairly exotic in one way, and then, brain study is very exotic in a different direction. And you couldn't just go to the store and buy one of these until recently, when now things are becoming available to, kind of more almost the hobbyist or a researcher can easily get something from a different field nowadays.
Yeah, it's difficult enough to do one of them right, to integrate them together. Do you have anything to add to that, Palmer?
Nothing really that useful that they haven't covered, except to say that it's not just that they haven't been available. It's maybe been even worse than that, has been that they are available and bad. And that's bad for, I think, both things. When a product exists and people try it and they say, this is bad, and then it actually hurts even the companies in the future that are doing it right. But I think that in things like brain monitoring and also in virtual reality, the technology is finally getting good enough where people can make really good, compelling products and hopefully overcome that stigma of, this is garbage.
Okay, so that leads nicely into the next question, which I'll call neuro reality. Is what could the audience? I'm sure that there's lots of researchers here, lots of game developers. What would you like to see them working on, or what are the next steps as far as integrating virtual reality and neuro gaming concepts together? Oh, I'm asking you guys. Then after that, the audience, you get to ask the panelists questions. What would you like to see audience, researchers, game developers working on as far as neurogaming and virtual reality? That must have been a tough question.
I just want to make sure I understand the question. What do we want?
What would you like to researchers, outside of the panelists up here, what would you like to see done, or what are the next steps that need to be done to really integrate neurotechnology and virtual reality together?
Research being neuroscientists working on.
Or virtual reality researchers as well.
Well,
Look,
Now everyone wants to go.
I would like neuroscientists, virtual reality, developers of applications, virtual reality. I would like everybody, I hope everybody would like to deliver an experience that is as close as we can to reality, but whether they are creating rehabilitation or wellness applications or education or training or gaming for entertainment purposes, it just needs to enhance the experience to the point that I can use my years of experience and use my intuition. So the brain is where the intuition resides. So for me, and we are working with neuroscientists, we are working with researchers, we are working with many universities. Oculus announced a big initiative with universities all over the world. This is the goal. Get the experience to the point that I cannot tell the difference between reality, or actually virtual reality will be a much better experience, hopefully, because reality is not exactly cutting it.
I guess I have something to add. One of the key things about virtual reality is that you want to induce a sense of presence. You want a person to feel like they're actually in a virtual environment. And that's actually not just about creating things that they can believe in. It's about minimizing the things that they won't believe in. And a lot of times that means making game design decisions or technology decisions that are based on, how can I keep a person in this virtual environment and keep them believing they're in a virtual environment? And sometimes it's tempting to add in a feature that works 90% of the time, 80% of the time, 50% of the time, because it's cool when it works. But when it doesn't work, it's going to ruin the experience and remind them that, in fact, this is all a joke and it's not real. I think that's one of the biggest problems right now with brain monitoring equipment, especially in the consumer sector, is that it's not actually reliable enough that you can use it to trigger anything that the user can measure. And if you do want to do it, like, wow, I want to use my brain to turn on that light, with my brain, that's something that's very cool, and it's something we wish we could do in real life. We wish we had that power. But if it's only working 80% of the time, it's just going to remind people that, this isn't real, that in fact, this is just something that works kind of sometimes. So I'd like to see people remember that when they're integrating their technology with virtual reality, that it isn't just about adding things on a feature list, adding more and more things that you can do. It's about making sure that the overall experience is something that your user can believe in. And maybe that means using the technology in more subtle ways to do things that frankly aren't as exciting. But if the user doesn't notice things going wrong, that really helps.
Just before Rick takes over, I just want to tell you something that a general in the Israeli army told me back years ago when I came to my reserves, that the goal in a simulator that we built needs to be that the quickest the soldier forgets that he or she wears and has using any technology, the better our product is. Meaning, the HMD of those days, of course, could not achieve that objective. It was 40 pounds. The tracking was also very clumsy, and it was wired. It was a very difficult overall experience. But today, we are very close to be able to put the Oculus on your head. Obviously, Sony's Morpheus also. Politically correct, we have to be here. But the thing is that it is when you put the controllers in your hands, like the STEM controllers, and you are able to interact with the world, and you are within seconds forgetting that you're using controllers, forgetting that you have an HMD on your head. That is the goal. So everything that we are doing needs to be targeted to one and simple focus. Make it transparent to the user. Make it so the user does not remember. And the moment that you achieve that, then your brain now is connected in virtual reality just like it is in reality. And then we achieved our overall mission.
Yeah, I mean, maybe going forward with that a little more. Right now, the display and the audio, those technologies, I think those are engineering problems. They're hard, but they have a path that is clear. The interaction technologies don't have such a clear path right now, so we need more work in that area for sure going forward. And one of the things that we found the most useful is not trying to replace one interaction technology with another one. A lot of people try to get rid of the joystick or something like that. That's not really necessarily the best route. Adding new sensing and not trying to get rid of old sensing that already works seems to be a very positive way to approach the problem. And along with that, I think actually another thing that we could benefit from a lot is thinking about these experiences in a broader way. I mean, we're a gaming company, and our focus is pushing the boundaries of play, making new ways to play. But actually what that means is not just taking an existing game and sticking it in VR. So we want to see experiences that are fundamentally games, but they're different games than you've ever seen before in VR. So seeing a really broad approach to the problem. I think we've already seen that, but we want to see that continue. So.
Absolutely.
Yeah, to me, I would love to see both sides. So people developing virtual reality applications, to treat patients, with the stimulation, with brain monitoring. And on the other side, I think you shouldn't underestimate that the more games and neuroscience we put into the market and into applications, the more knowledge we'll gain. I'm coming from Europe. When we have this big initiative on the human brain, so do you in the States with the Obama Brain Project. So I think that this is a challenge for humankind, to discover how our brain works. And I think that all these technologies are going to push the science in a tremendous way, because all that data that we can collect can help to develop EEG biomarkers, to know the way we interact with the brain, to make drugs more effective. So I think that all this community, the gaming community, can help a lot to the brain science. So I think that that's a treat we can give to knowledge that it has tremendous value.
Yeah, and I just want to add a little bit to that. You know, some of us think about virtual reality, the technology isn't there yet, but with what all the panelists here have been working on, it's getting to that point that the technology is almost good enough. It's going to be largely solved very soon. However, it's not just about the technology, it's about human physiology. For example, you know, you got to get the latency down in the head-mounted display, but there's other challenges such as, you know, the sense of balance based on your vestibular system in your inner ear. If you're flying forward, but you don't physically feel like you're moving forward, that's not a technical issue. That's, you know, understanding human physiology and how to deal with that in these non-natural ways. So I think there's some big challenges there outside of the technical side, understanding the psychology side, the neuroscience side, those sort of non-technology driven challenges. Okay, with that, I'd like to open up questions to the audience about neuroreality. Who has a question? There we go. Do we have another mic for the audience? I can bring it down.
Hi, my name is James Blaha. I'm working on a lazy eye treatment.
What's your name?
James Blaha.
Oh, I thought you said James Bond.
Yeah. James Bond would be better. Yeah, my name is James Blaha. I'm working on a lazy eye treatment that uses the Oculus Rift. I was wondering if the EEG data is good enough for me to see what's going on in the visual pathway, and if the stimulation is targeted enough for me to stimulate specific parts of that pathway.
No.
Maybe 5 years. Well, Palmer can further elaborate. No, so there are certain things you can see in the EEG. As far as your question, I think that there is not yet evidence on the brain stimulation side and vision. We are doing some studies with multiple sclerosis and visual impaired patients, but that particular application is yet at the research level. We have been more successful in things like attention, you know, cognition, memory, motor rehab, you know, things like depression, mood. But I think it will come soon because we have some evidence that may work, but it's in a very little number of patients, so you'll have to wait some more time for that particular one. But we can keep you posted. I think it will get to a point where you can, I mean, one of the dream things is can you kind of replay emotions, you know? So now that we can write into the brain, can you record an emotion and in the future play it back? You know, that's science fiction. When we started this project, we wanted to do brain-to-brain communication, so we asked the European Commission, listen, we want to do brain-to-brain. Would you fund us a study? And they say yes. So they gave us a few millions. And then we did the EEG was the reading part, and then we were missing the brain stimulation to do brain-to-brain. So that's why we developed this whole area of brain stimulation. So the things that look like science fiction no longer are science fiction. So technology is enabling that. So I think it will come to a moment where we'll see that closed loop in a very real-time, fast way for, you know, for this particular application.
That brings up a great question, what I was saying earlier about limitations of the technology that isn't quite there yet. But what are the limitations, the constraints, even with, you know, 10, 15 years of improving upon the sensors and such? What are the inherent limitations of, you know, if we had the perfect equipment, we still may not be able to do some things? Do you see some limitations of what can be done with those sensing technologies?
No, I mean, no, I think that it's about technology. I mean, it's like the virtual reality glasses. Years ago, we would never thought it was possible, and now it is. So it's a matter of time and technology. So
I would propose a counter, which is that not that years ago it wasn't ready, and it wasn't ready, but you know, remember when that CyberFace headset came out, were researchers saying, you know, we're not even close. It's going to be decades before our work is of any use. No, they were saying, you know what? This is only a couple years away. We're on the verge right now of having consumer virtual reality. I'm not saying that you're not, really close, but it's kind of interesting that technology, and I'm the same way. I think we're here, you're here, you're here. We're all here thinking that our technology is just about ready to burst into the consumer space. And it's interesting because technologists seem to have thought that many, many times over the course of all this advancement.
I mean, real quick, in direct response to your question, there are other sensing solutions directly monitoring eye tracking, for example, that could be used in that particular situation. So you don't have to go to the end ultimate sensing system for some things. So I think we have steps along the way that we can take, which will be still really interesting and useful.
I think that, like I said at the beginning, it's going to start strapping stuff onto the end in the real world, and then eventually, hopefully, maybe we figure out how to get more direct.
Just when is your system going to reach the consumer level of pricing and capability? Because obviously the Sony HMD and no, but when you see it at the level that will be sufficient for you, the data will be collected, will be sufficient.
So we chose the hard way. I don't know if it was the right or the wrong way, but we chose the hardware, and the hard way is to go to the medical community, go to the key opinion leaders of neuroscience, so that they will do serious studies with our technology, build the evidence, conquer the clinical world, prescribe home use, and then maybe the consumer will come. So or in parallel, I don't know. But I think that in these kind of technologies, you have to be careful, and you have to know very well who is using the technology, because you have well-designed studies and very bad designed studies, and they can ruin the technology and the whole field. So I have a lot of parents that write to us and say, I want to buy one of your devices to stimulate my kid. And I say, no way, you call your doctor called me, and I'll see, if he's in a research institute, he has an IRB approval, and then we'll do it right. So I think that is what you need. You need good people to take nice technology and do things right to build the evidence. So I think it will take some time for the consumer.
Is it 2 years or 20 years?
No, it's not 20 years.
Just a few years.
How many years did you think you were going to take to have a successful VR headset in the market, Palmer?
Just a few years.
And how long it took?
Well, we haven't done it yet, so we're selling development kits to game developers. We still haven't. It's so easy to forget and say, wow, Facebook, $2 billion. Wow, virtual reality, it's really taking off, but it hasn't actually really hit consumers yet. I
disagree.
Think from anyone.
My kids play with your Oculus at home with their kids, with their friends.
Did they check the box that says I am a software developer when they ordered?
His dad did.
Yeah, there's a great book called Crossing the Chasm of how it is. Early adapters are very different from the mass consumer market, so it will be interesting to see what happens.
In a way, I wasn't slamming your product. It was more just this. It's a thing that I think all of these new technologies share, where it's so easy to feel like it's just about to happen, and it's hard to know if it really is.
But it keeps us with passion to be able to wait for the moment,
Absolutely. Like I said, no researcher would have wanted to say back when the Cyberface came out, like, it's just not good enough. I'll just do this in 20 years.
Yeah, but I think that, again, what I'm going to say is not going to be very popular, but I think that it's people like yourself, which what I used to be back in the 90s, taking important technology and important brain trust, important experts, and moving it to the professional applications that unfortunately is going to keep that technology away from the consumer market, because you're going to have to go through FDAs and all sorts of approval processes that are, if your technology is ready and is as good as you say it is, in the hands of a company like a Facebook, a Google, or somebody like that, they can put the money and collect the brain power to make it available to the mass market. So for me, the goal for the company from the day I started and the day that we introduced it to the market was get everyone to be able to experience what professionals are benefiting when they have those budgets to spend. So when our technology is being now introduced into rehabilitation and wellness and pain management and all that kind of stuff, we are telling them the only way we will provide you access to our technology is if you will make it available in Walgreens and in mass market retailers, so consumers will be able to have access to it. Because I feel that when hospitals are charging thousands of dollars for something, it's just getting to the ones that have the money to use it.
Any other questions?
Hello, my name is Vadim Shubarov. I run a game developer studio, and recently been developments in cinematic VR, such as John. I'm sure you're aware. And I just want to know how will these developments blur the line between games and movies, and how this end product is distributed to the end consumer. Thanks.
So yeah, from a company that, we have a movie business and a gaming business, so actually I think that's a really interesting area. How you tell a story in VR is a really just as open as how you play games in VR right now. And I think it's going to be fascinating to see. I know there's already people working from Hollywood and from other parts that are looking at how to tell stories in VR. I don't necessarily think that it will make games and movies merge through VR. I don't think that's necessarily what will happen. I think it'll be really interesting to tell a story but still not be involved in the story directly. So you could imagine like, a Christmas Carol where you're just a ghost and you get to watch the whole thing play out, and you can watch it from a different point of view next time, right? So that's one way to tell a story. So I think that I don't necessarily see games and movies merging, but I think VR is a really interesting media for both those things, for telling a story and interacting with a game to be explored.
Any other comments?
I remember when pre any kind of fancy investments or buyout of Oculus, Palmer and myself were at a VR conference in Orlando, and we took a ride back to the airport when it ended. And I remember Palmer sitting in the back with the head of development for our Make VR product. And I was telling him that I feel that the Oculus is going to revolutionize the movie industry. And I am not a movie maker, but my co-founder of the company is one of the biggest producers of movies in Hollywood. His name is Avi Arad. He just released the latest Spider-Man. And for him, and for a few others that I know very well, being major players in the movie industry, this is bigger than tablets. It's bigger than iPhone. For them, it's a whole new way to market their movies. Meaning, I would have invested a lot of money right now, and they are investing in Netflix, because when Netflix starts streaming into the Rift, it's going to be gigantic.
I'm going to pretend to be clever and come at your question from a different angle. You talked about blurring the lines between movies and games, and you mentioned, you don't necessarily think movies are going to become games or vice versa, and I think that that's true. There's going to be these very passive experiences, but that's more on the user side. I do think that where games and movies are going to blur together is going to be more on the technology side. I think that we're more likely to start seeing real-time rendered movies, especially when that gives you such significant benefits, like being able to move at least a little bit through the scene so that you can get translation and parallax effects. Compared to when you're filming something, you're, at least right now, until we start capturing, depth maps of the whole scene or full light field capture. We're going to be very limited in what we can film with cameras, even stereo cameras and even 100 stereo cameras all stuck together. So I think that's where the blurring between movies and games is going to come, is on the side that the consumers never even see.
Actually, going back, I'm going to age myself a lot, but going back to the Genesis, I worked with Sega back in 91, I think, 92. They released the Sega Genesis, the Sega CD. It was kind of stuck on top of the Genesis into the cartridge port. And Sega, it's funny enough, it's the general counsel of Sony now, Riley Russell, that was he's credited with one of the interactive movies they created. If you take a look at those movies in those days, again, we're talking more than 20 years ago, got significant, significant good reviews at the time. My point is, it was a very interesting form. It was a movie. It was shot with a movie studio in Hollywood, in Burbank, and it was very, very interesting. I don't know if you've seen those. Okay, so that's very, very interesting. Exactly, so that's one. But then, I believe that there are some game studios today that are very innovative, and The Walking Dead, as an example, I'm just listening to my colleagues here talking. The Walking Dead can very quickly, I believe relatively, for any other game that exists today, the format of The Walking Dead can be adapted, interestingly, into virtual reality. I can see it quite easily adapted.
You're talking about the episodic games.
Yes. That is going to be a perfect thing, I think, as a start. Because I agree 100%, everything for VR needs to be designed and understood from the VR perspective. So it's games, it's movies, meaning we have 3 game designers in our Sixense studios, and they've been spending the last 3 years learning how to design for VR from scratch. They are Sega designers, they are the designers of typical AAA games. We took them, and they are basically adjusting the mindset for the new medium. Exactly. Yeah.
Well, you could also take the inverse of that. Instead of the end user, what about the content creators? I think, Amir, you probably have an opinion of that. We have, virtual cameras and virtual sets and such. Well, I know you especially have an opinion about this.
I just, I've been there for a long time, and I've been seeing, I'm a believer that content, everything is about the developers of content. It's all about them. We are just answering to what they envision, what they're trying to do. It's amazing to see how, and don't take it the wrong way, Palmer, but Palmer is able, or his team is able to acquire all the Valve team. All the HMD team in Valve moved into Oculus. The result of that is that suddenly the same people in Valve could not listen to anybody. They were not allowed to talk to the outside world, which is a Valve mentality thing. That's how they run things, and it's very different. And you look at the way at Oculus they're working. It's all about listening to the world, going to the university and listening to them, going to the content developers. I know the guys that are running the third-party developers for Oculus. This is a whole different approach, listening to the developers. What do you need? We took the STEM, and all the time, working with over 3,000 developers, basically, all over the world, we are continuously changing the product and making sure that it is better for what they can envision being the experience they're trying to create. And that is something that you need to be a smaller company, even though now they're a smaller company within a big giant. Same thing for us. Fortunately for Rick, he's got a little problem in there, but
No, I mean, it's well documented that the PlayStation 4 design was done in conjunction with all the game developers, and that, we really created that platform together.
Yes. Yeah. Let's talk about
that too.
Let's talk about Morpheus being done with
Morpheus also.
yeah, of course.
Yeah, I forgot to mention those. I'm sure you're very aware of the Oculus Rift, but also Richard has been very involved with Project Morpheus, which is a head-mounted display by Sony. So whenever you get a chance to check that out, definitely do so. And we have a couple minutes left, so maybe one more really quick question. Here we go.
I have a, is this working? Yeah. Who's asking the question?
Okay. Whether or not there we go. Whether or not, I'm Richard Varn with Educational Testing Service, and one of the concerns about education is we're not able to individualize instruction very well, in part because schools aren't designed for it. So virtual reality gives us an opportunity to do the 4 things you need to do, that you can individualize instruction, which is see, speak, hear, and interact without disturbing those around you. So have you guys considered how you might become more involved with education, or are you just really focusing on getting it into the gaming space and establishing it as a platform first?
I can speak. So I can speak about specific application we're working right now. I'm very excited over that, even though it's not something like mass market, but it's obviously a good fit for VR. We are working with one of our longtime partner and a user of our STEM technology that is educating both teenagers in high schools and college and all sorts of different educational facilities to do welding. Welding, more than any other training or application for education, fits perfectly because it's got an HMD as part of the overall experience. The only difference is that they just had to replace that kind of see-through plastic looking at a display. We just told them just stick the Oculus in place of that, and that's it. That's all you need, and they did it, and it's been unbelievably successful. They've already been in the market for 2 years. Now they are hopefully gonna release it with the Oculus for testing, and that will be, I believe, a huge success. Now they're following that with carpentry and many other, painting and many other things that in schools are a big push for. But I believe education will be bigger than gaming, training will be bigger than gaming, and we're definitely pushing towards that.
And with that, I think we better wrap up for respect for our next panelist. But I also want to mention I've been working with Sixense Entertainment on a neuroscience education project by NIH. So educating our kids how their brains work, right? That's not normally maybe taught in that curriculum. So I think there's huge potential there. Okay, with that, make sure you guys check out the booths here. They have, I know Richard has a booth, Anna has a booth, Amir has a booth. Do you guys don't have a booth here? I'm sure there's a couple Oculus Rift head-mounted displays.
You can come to our booth and experience his early prototype.
All right. Okay. Thank you, everyone, and thank you, our panelists.